so this one we are going to have what kind of figure formed? A triangle. You can expect to have some triangles show up on your test. So we have a balloon is rising at a constant speed of 5 feet per second. So this balloon is going up, and here's my balloon. All right, and so I'm going to call that maybe my y. And so the speed is dy dt is 5. Okay, then we have a boy that is cycling along a straight road at a speed of 15 feet per second. So this boy is traveling along. He goes underneath the balloon. So my dx dt here, his speed was 15. When he was under the balloon, it was 45 feet above him. So at this particular instance, the y was 45. But he kept moving, the y kept moving. I want to know how fast the distance between the boy and the balloon, I call that z, is increasing. So we know that's not a constant. So we're trying to find that 3 seconds later. So keep in mind, the balloon started out 45 feet above it. But every second, it went up an additional 5 feet. So in 3 seconds, it was at 45. So 1 second after that, it would be at 50. 2 seconds, it would be at 55. So 3 seconds later, how high was the balloon? 60. Does everyone understand where that number came from? All right, and if he was going 15 feet per second, then in 3 seconds, how far has he gone?
45.
All right, and we could find z at that particular instant, couldn't we? So we know 45 squared plus 60 squared equals z squared. So what do you get for z at that instant?
75.
Okay. So squared plus y squared equals z squared. You have to be careful on this. Sometimes we have something where when we do the derivative, a variable completely disappears and turns into 0. When does that happen?
When you plug it in too early.
If we plug in too early.
Oh, it's constant.
And also if there's something that's constant. So ask yourself, before I do the derivatives, are there any constants here? No, so I have to keep everything. So derivative of x squared is 2x dx dt. Derivative of y squared would be 2y dy dt equals 2z dz dt. So then if we plug things in, make sure you're writing this line. I think I talked about that Friday. Don't try to plug in at the same time. Show me the derivative and then plug things in. All right. So 2 times 45 times 15. So you get dv dt equal 13, and we were in feet per second. It's a rate, that's why I know I need those derivatives to be something per something for the units. Is that one okay? Okay, so we have done a lot of problems like this with triangles. We've done some where like we had a ladder sliding down the wall. In that scenario, are there any constants?
The ladder.
The ladder would be a constant. If I had, didn't we do one example with like a boat being pulled into a dock or something, and the dock was a certain amount above the ground or above the water, so the dock, the height of the dock was a constant there. We've done one where like you had two cars that started at the same point and they were traveling different directions. Would there have been any constants in that scenario?
No.
No, you would have all three sides to take into consideration. But on all of these triangle problems, we ultimately end up doing Pythagorean theorem. and working from there. Okay, number 5. So we have a funnel in the shape of an inverted cone. Here's our waffle cone. Okay, it is 30 centimeters deep and has a diameter across the top of 20. So the height of this thing is 30. The diameter all the way across is 20, so that means the radius is 10. Now that's for the entire cone itself. Liquid is coming out at a rate of 12 cubic centimeters per second. What does that represent?
dV/dt.
And since it's coming out, it would be a negative. What are some other instances where we have negatives? Like when something is falling, that's a negative. Leaking out, that's a negative. Okay. Then, at what rate is the height decreasing? So I'm looking for dH/dt. When the liquid is 20 centimeters deep, so at the instant when the height is 20. Now if you go to, look at this, volume of a cone is 1/3 pi r squared h. What would happen if I did this derivative right now?
You're gonna get zeros. Oh, no, we're gonna get like dr.
We're going to have a dr dt, a dH dt, and a dV dt. Did I give you any information about r? No. If that happens, you want to get rid of r before you do the derivative. Otherwise, we're in trouble. So, come back to this whole thing. Okay, let's think of this as a triangle. Here's the height and here's the radius. So, if I set up a proportion, I could say 10 over 30 equals r over h. So we're solving for r. So r is 1/3 h. So 1/3 squared is 1/9. So this will give me a pi over 27. H squared times h is h cubed. And this is much better to take the derivative of because now I don't have to do a product rule. I can just work from here. So dV dt equals pi over 9 h squared dH dt. So plug in negative 12 equals pi over 9 times 20 squared dH dt. Now obviously on the test I either have to give you nice numbers or I may say, you know, set up but you don't have to solve it all the way. Something, but we have a calculator for this. So I have to multiply all that and divide it over. So a couple ways you might write it. It's like 2025, no, sorry, negative 27 over 100 pi, or if you put it all in, it's like negative 0.0859. What would my units be? Centimeters per second. My height is centimeters, time is seconds. Any questions on that one? So, probably going to be one like this on the test. There have been multiple times where we had to find that r before we did the derivative. All of them dealing with these cone type problems. So, you know, your test is like 10 questions. There's only like 12 on here, so probably pretty similar. You guys are good for one of those? Number 6, this was from the homework. So it told you that the circumference was 90. The possible error, how do we denote error? dc was 0.5. I want the maximum error in volume, so I'm looking for dB. volume of a sphere is 4/3 pi r cubed. Okay, I would give you that formula if you need it. Basic things you should know, like Pythagorean theorem, area of a circle, circumference of a circle, area of a rectangle, those kinds of things you should know, but I would give you this. So if I do this derivative right now, derivative of v would become dv. 3 comes down, so that's 4 pi r squared dr. But I don't have r and I don't have dr. So what can we use? Okay, I know that circumference is 2 pi r. My circumference was 90. So if I solve, the radius is 45 divided by pi. Okay, now we need to find dr. So I know dc. If I did the derivative of this, dc would be 2 pi dr. So if we plug in, .5 divided by 2 is 0.25 over pi. And so then we can get dv. I would probably just put all this in my calculator. It is pretty ugly. And you get 205.175. V is volume, cubic centimeters. So it's saying if my circumference might have been a ½ centimeter off, then my volume is going to be 205 cubic centimeters off. Questions on that one? So probably expect an error question. You know, just recognizing that if I ask for the error in something, that's dV or dr or dc, whatever I'm calculating the error of. All right. Next question we asked was number 9. So differential. This would be a great multiple choice type question. Differential is just another way of saying error. We know that in general, derivative of y is dy dx or y prime. So let's say if I just wrote dy dx for a moment. Then this is just doing a derivative like we did before Christmas, derivative of the log. So a derivative of a log is 1 over the argument. But since the inside isn't just a plain x, we have to do a chain rule. So times derivative of the inside. So derivative of x is 1 plus a square root is like a 1/2 power, so the 1/2 comes down. Inside stays the same. Subtract 1 from the power times derivative of the inside, 2x. Right, so that's a little chain rule there. All right, if we want to clean this up a little bit, a 1/2 and a 2 would cancel. So we have this. And then that was times x, so that could become an x. Okay, different ways you could write this from here. You know, you could distribute or whatnot if you wanted. It's not going to clean up a whole lot. But we're solving for the differential, so what did we do at the very end? The differential is just dy, so you essentially just multiply over the dx. So the differential is just the derivative times dx. Saying the change in y is the derivative times the change in x.
Okay, but why did you not take the 2x times the 1 also?
because it was only multiplied with this term.
Oh.
And it's all part of that chain rule for the square root. Do you guys want to try a similar problem with maybe an inside that isn't quite so ugly? Like, what if I just took out the x here? I think maybe if we had a simpler function to start with, then maybe we could see it a little bit better. So if I had said square root of, let's just do 1, or x squared minus 1. We'll just take out that first part. So the differential, dy, we know that just means we're going to have a dx on the end. So the derivative of a natural log is? Okay. So the derivative of the square root, 1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, 2x. Okay. So then, 1/2 times 2 cancel. We have 1 over this. What would a negative 1/2 power do?
Bring the square root to the bottom.
And just have an x left. So these you could even multiply together and drop the square root, so it'd be x over x squared minus 1 dx. Much prettier that way if we had just a slightly simpler function in the inside. Is that one okay? Alright, question number 11. So we only asked about part of this, but let's go through. This would be great. I told you your test has like 2 questions that are worth, or that have more than one part. So if you can look at your study guide, you can probably predict what 2 questions am I going to put on there that have more than one part.
Probably this one.
And then maybe 10.
Yeah, probably something about marginal cost and something about velocity. If I were a betting person, that's what I would assume. So,
I'm not much of a gambler, so.
I know. Well, you know, I'm a pretty
Blackjack.
conservative. All right, so this one tells me my height. Okay, on these questions, it's not necessarily that the math is difficult, you just have to know how things are related. So if I ask for the velocity after 2 seconds, how do you get velocity from height?
Derivative.
Velocity is just your first derivative. So 15 minus 3.72 t. So that's my velocity equation. So if I ask for the velocity after 2 seconds, you're just plugging in a 2. Obviously your test will have some fairly nice numbers to deal with, but what do we get?
7.56.
All right. Then, I asked you, what's the maximum height? How do you find a maximum height, or a maximum distance, or a maximum anything? Derivative equal to 0. Okay, whether something is going up and coming back down, or if I'm rolling a ball and I roll it forward and it's going to hit the wall and roll back, when I find that maximum, the velocity stops there because it's changing direction. So I'm just going to take my derivative, which I already found, and set it equal to 0. So you get t equals what?
4.03.
And you can have it as a fraction. It's like 125 over 31. If you rounded it, that's also fine. And then I asked you for the actual maximum height. So this is the time, the when it happens. So the height, you have to plug that in. So whether you put in the 4.03 or this, you might get a slightly different answer. depending. I think I did the actual fraction and I got 30.24. If yours was slightly different, that's just because you rounded your original time. Again, obviously, tests, it'll be nice numbers. All right. So part C, I want to know the velocity when the height is 25. Okay, so I have the position, and I want the height to equal 25. So I'm going to set the original to 25. It's a quadratic, so I'll bring everything over. I'm probably going to have to do the quadratic formula on this. So opposite of b plus or minus the square root of b squared minus 4 times a times c over 2a. And then can I just tell you what you get when you put that in your calculator for the sake of time?
Mm-hmm.
Okay, so I get my times. Then what did I ask you to find? The velocity. So you have to take those and plug them into the velocity equation, or the first derivative. And I think we get 6.258 on the way up. I know it's going up because it's a positive, and then when I put in this one, I get a negative because it's coming back down. So that's on the way up, and this is on the way down. Part D, we didn't specifically ask about this one, so let's just talk through it. I want to know when the rock hits the ground, so what do you have to do? The original equation, the height equal to 0, and you guys could solve that. Part E wants the acceleration. How do you find the acceleration? Right, second derivative, or the derivative of velocity. Mm-hmm.
Where did you get 5.71?
When you did the plus.
Oh, plus and minus.
So two different answers. So acceleration will be the second derivative. And if you do this derivative, you just get a negative 3.72 for part E. Part F was the velocity when the ball returns to its starting position. So the ball started on the ground. So when it returns to its starting position, it hits the ground, right? And in part D, you found that it hits the ground after 8.06 seconds. So you are plugging that into your velocity. And you should get negative 14.9. Okay, so all those questions are really just testing, do you understand the relationship between your function and the derivative when we're looking at the height? Let me ask another question. What if I said, your height equation is and I want to know when is the velocity, make sure this is going to work. Let's say 139. So my question is a when. So you are finding a time. But I'm telling you the velocity, and the equation is for the height. So how do you get from this to the velocity? Derivative. So my velocity would be 3t squared plus 6t minus 5. And I want that to equal 139. you do at this point if you're trying to?
The factory.
Yeah, let me factor. Couldn't we divide everything by 3 here? Let's see. 144 divided by 3. So, multiply negative 48 and add to positive 2. 6, positive 8. You get 6 and negative 8. Are both of those possible? Can you have a negative time? No. So how long does it take? 6 seconds. Okay, so I could give you something to plug in. You just have to watch. Are you putting it in the original or the derivative and solving from there? All right, so are you prepared for a question along those lines? Finding velocity, maximum height, those kinds of things. Number 12 is really just checking if you understand what a derivative means. It tells us we have a square here. So we know in a square all the sides are the same, and it even told us in the problem that the side length is x. And we want to know how the area changes when the side changes. How do you find the area of this?
X times width.
Times width, so x squared. So the derivative of x squared is 2x. And I asked you to find the derivative when x was 15. So you get 30. So that's your a prime of 15. Then explain what it means. Remember, a derivative is a rate of change. So it's saying when the side length is 15, what was I in, millimeters, the area, it's not saying the area is, it's a prime, so the area is changing. Since it's a positive, it's increasing by 30 square millimeters. I think on question number 10, when I had the marginal cost question, it kind of related to this on part B as well, asking you to describe the meaning. So I put a couple of them on here. You might see one show up on your test. If you have a cost function, how do you get a marginal cost?
Derivative.
Derivative. Then if I ask you to interpret it, so on like number 10, we had c prime of 100. So you did your derivative, you plugged 100 in, and you got 0.1. What does that mean?
When there's 100, the cost increases by 0.1.
Right, when we make 100 items, the cost is increasing by 10 cents an item. Okay, it's not saying it costs 10 cents to make 100 items, it tells us how the cost is changing. A derivative is a rate of change, how something changes. If I ask for the actual cost of making 10 items, or 100 items in this case. So let's look at 10. If I ask for the actual cost of making 100 items, what would you do?
Put in the original.
Okay, put 100 into the original. What do you get for the true cost of making 100 items?
You said 100?
Mm-hmm. Okay. So the actual cost is $9.90. And in part B, we found that c prime of 100 was 0.1. So with this information, how much do you think it would cost to produce 101 items? Yeah. You just take the cost of making 100 of them, and we think the cost is going to go up 10 cents. So we would predict it to be 990.10. That's what the derivative is telling us, how the cost is changing. Does that make sense? We have gone through all the questions you guys specifically asked.
Wait, so how do you word 10C?
So you would find, I asked for the true cost of producing, so if you plugged 101 into the original, you get 990.10107. So the actual cost went up just over 10 cents. So our approximation was really close. It was just off by a little bit.
Oh, you put it in the original?
If I asked for the true cost. Because it said compare C prime of 100 with the cost of producing the 100. We did not do any linear approximation ones. You'll probably have one of those, like number 8. Do we need to talk about that? No linear approximation. You have to have a point and a slope.
Yeah, probably, but.
Okay. Do you want me to make up a different one?
Yeah.
All right. So what if I said, find a linear approximation to estimate. Did you get it?
No, it's fine.
Well, here, let's. So if I asked you to estimate this using linear approximation, what would we do? So our function would be the square root of x. Or you could write it as x to the 1/2 if that's easier for you. What's the nice point we would use? If you plug in a 36, you get out 6. So there's our point. We need a slope. So the slope is the derivative. So when half comes down, subtract 1 from the power. That's like 1 over 2 square root of x. So to get the slope, what am I plugging in for my x? So I get 1/12. So now I have a point and a slope, plug into y equals mx plus b. And I get a y-intercept of 3. So my linear approximation is 12x plus 3. If I asked you to actually approximate the 37, you're just plugging that in. And getting your answer from there. 37 divided by 12. Got a few minutes. So we've talked about velocity, we've talked about differential, we've talked about linear approximations, talked about marginal cost. We did a cone problem, we did a triangle problem, we did a maximum error. Let me just make up a problem. So, all right, let's say the base of a rectangle so the base of a rectangle is increasing, let's say 6 centimeters per minute, and the height is decreasing 2 centimeters per minute. At what rate is the area changing? When the base is 50 centimeters and the height is 80 centimeters. So what would I do?
Make a triangle.
Square picture time.
Kind of threw you. I said base and height, which you usually hear me use when I'm talking about triangles, but this did say rectangle. So you can call it, base and height. You can call it length and width if you like, whatever. So the base was increasing 6 centimeters per minute. What does that represent? And the height is decreasing 2 centimeters per minute.
-2.
dH/dt is -2. The base is 50. The height is 80. So what would I do? I'm looking for how the area, the A to T is my question mark. How do you find the area of a rectangle? Length times width, or base times height if I use these variables. What would I have to do this derivative?
The product rule.
Yes. So the derivative of A, dA dt, equals derivative of the first, so dH dt, times the second, plus the first, times the derivative of the second. Please write this step. And then we just plug in stuff. dH dt is -2, B is 50, or H is 80, dD dt is 6. Look, I even gave you one that you could do without a calculator just to help you practice for the test. So we get -100 plus 480, so 380. What would my units be?
Centimeters squared.
Per minute. What? Is that 5 minutes?
I feel like I'm gonna kill this test.
Good.
I was very worried about what was gonna come out of your mouth when you said I'm gonna kill.
No.
You're the one who says that a lot.
No, I don't.
Just because of my anger last hour.
My anger? Were you bad? Oh, you did curse. I think you said an F-bomb in front of.
No, I